Alright kids, here's number 8. Please ignore all the, hey, when I printed it out again, it gave me different numbers. So here are the numbers that you'll see. You're welcome to use these numbers as well for practice on your own. Number 8, let's do it. How many grams of H2O will be formed when 32 grams of H2 is mixed with 42 grams of O2 and allowed to react to form water? Well, first, we need an equation. Okay, so H2 plus O2, and how many grams of H2O will be formed? There it is. So H2 plus O2 gives you H2O. Is this balanced? We got 2 H's. Looks good. 1 O, 2 O's? Nope. Let's do this. Now that means that we need 2 of these. Now it's balanced. 2 of these and 1 of those gives you 2 of those and 1 of those. Okay? Got it? Lovely. That's the first step, is get a balanced equation first. So the question is, how many grams of H2O will be formed when you have this many grams of this and this many grams of this? Anytime you have 2 amounts of the reactants, it's a limiting reactant problem. And the only way to know the limiting reactant is to determine which one creates the least amount of product. So let's see. Let's start out with our 32 grams of H2. Okay. 32.0 grams of H2. So we're going to go through the whole equation here. We're going to go from grams of H2 to moles of H2. Once I have the moles of H2, can I find the moles of H2O? Absolutely, because for every 2 moles of H2, how many moles of H2O do I get? 2 moles of H2O. Very nice. And then for every 2 moles of H2O, you can actually stop at moles, but I like to go all the way to grams because that's usually what they're asking. So 1 mole of H2O is how many grams of H2O? This is getting a little messy, sorry about that. And this should give you grams of H2O. Let's do the same thing for O2. Well, actually, let's finish this out first. What is the molar mass of H2? It's 2.016 grams of H2, not 1.008. That's for 1 H. This is 2 H's. And the weight of H2O, which is oxygen, is 16, hydrogen is about 1, so it's like 18.016. Okay? All right, so grams of H2 to moles of H2 to moles of H2O, and it'll give you grams of H2O, which is 286 grams of H2O. That's if you use up all the H2, that's how many grams of H2O you'll make. Let's do the same thing with O2. Let's switch to red. Why? I don't know. Spice it up. 40, with a freckle, 42.0 grams of O2. So let's convert that into grams of H2O. Alright, I'll try to make it a little bit more legible. I'm going to try to go horizontal instead of this way. So let's go from grams of O2 to moles of O2. Once we convert from grams of O2 to moles of O2, then we go to moles of H2O. And notice that for every 1 mole of O2, there is 2 moles of H2O. So it's a 2-to-1 ratio. 1 mole of O2, making sure these cancel. 2 moles of H2O. Very nice. And now we're looking for weights. 1 mole of H2O is 18.016 grams of H2O. Do the math. Remember in your calculator, it's 42, put in parentheses, 42 times this, times this, times this, divided by this times this times this. Oh, and by the way, 16 times 2, 32.00, okay, in your calculator. And you're going to end up with something like 47.3 grams of H2O. So, the limiting reactant is the reactant that gives you the least amount of product. So, which one is that? Well, look. The only way to know is to find the moles of the product or the mass of the product. You could stop here and find the moles and then go from there. Oh, why not? So this is due to the limiting reactant O2 is limiting. It's the cheese. It's the one that runs out first. If we had more than enough O2 and we could use up all of our hydrogen, we would get this much. But we don't have that much. We only have this much. This is the maximum amount possible that we can make. So let's take a look at our answers. Nope, nope, nope. Hey, look at that. Okay. Hey, by the way, look for some of the traps. This is half of that number, which often happens if you mess up with the molar mass of one of these. And it's also in a fourth. That's if you do H and O. So these problems, these numbers can be traps. One good trick, by the way, is write your own answer first and then look at answers, just in case.